What if you could rent a global supercomputer by the minute and never buy another server rack again? That idea is the heart of Microsoft Azure. Azure is Microsoft's cloud computing platform. It lets teams build, manage, and deploy applications on a worldwide network of Microsoft owned data centers. Instead of owning hardware, you rent capacity that already exists, already secured, already connected. Here's why that matters. A startup can launch in one region today and expand to 5 continents tomorrow. A bank can train a machine learning model overnight without buying GPUs. Azure is the utility layer under modern software. Infrastructure, platforms, and ready made software, all delivered as a service. In this lecture, we'll open the box, how virtualization makes it possible, how Azure's Fabric actually routes your request, which services you get, and why organizations trust it for production work. Cloud isn't one product, it's 3 layers of responsibility, and Azure sells all 3. First, infrastructure as a service, IaaS. Think virtual machines, disks, and networks. You still manage the operating system and apps, but Microsoft owns the physical hardware. It's like renting an empty apartment. The building is theirs, the furniture is yours. Second, platform as a service, PaaS. Here, Azure manages the OS, runtime, and scaling. You bring code. Web apps, managed databases, and functions fit here. More like a furnished apartment. You move in and start living. Third, software as a service, SaaS. The whole application is ready. You log in and work. Think Microsoft 365 style experiences sitting on Azure. Azure also layers advanced capabilities on top: artificial intelligence, machine learning, and Internet of Things. The key insight: pick the highest layer that still gives you the control you need. Higher layers mean less ops work, lower layers mean more flexibility. That trade off is the whole game. So, how does one physical server become dozens of independent computers? The answer is virtualization, and Azure is virtualization at planetary scale. On a traditional machine, the operating system owns the hardware tightly. Virtualization inserts an abstraction layer called a hypervisor. The hypervisor emulates a full computer for each virtual machine. It hands out CPU time, memory, and storage so multiple VMs can share one server safely. Each virtual machine can run its own operating system: Windows on one, Linux on another, side by side on the same metal. From the guest OS's point of view, it has a complete computer. From Azure's point of view, it's just another schedulable slice of a rack. Here's the part that matters. Once you can slice hardware this cleanly, you can rent those slices on demand. That single idea is what turns a data center full of servers into a cloud. Azure doesn't stop at one hypervisor. It repeats the pattern across entire data centers owned by Microsoft. Picture a data center, rows of racks, each rack packed with servers, each server running a hypervisor, and many virtual machines. Network switches stitch every server together so traffic can move between racks and out to the public internet. But who decides which rack gets your new virtual machine? One server in each rack runs special software called the Fabric Controller. The Fabric Controller watches the health of that rack and creates or repairs virtual machines on demand. Above the Fabric Controllers sits the Orchestrator. The Orchestrator is the brain that answers user requests. It chooses the best rack, packages what the VM needs, and talks to the right Fabric controller. Users never speak to individual servers. They speak to the Orchestrator, and the Orchestrator makes the Fabric move. Let's walk the path from I need a server to I'm logged in. 4 steps, end to end. Step 1. The user makes a request through the Orchestrator's web API to create a virtual machine. That request can come from many tools: scripts, CLIs, or the Azure Portal UI. Step 2. The web API receives the request. Whether you clicked in the portal or ran a command, it lands in the same Orchestrator interface. Step 3, the orchestrator packages everything needed for the VM. It picks the best server rack, then ships that package and request to the Fabric controller on that rack. Step 4, the Fabric controller creates the virtual machine on a server. Once it's ready, the user can connect, typically over remote desktop or SSH. That's the real world loop. A click in a browser becomes a coordinated decision across orchestrator, fabric, and hypervisor, and a live machine appears in minutes. Once you understand the fabric, the service catalog starts to make sense. Begin with compute, the engines that actually run your code. Virtual machines are the classic IaaS offering, full control of an OS image, size, and disks. Virtual machine scale sets take that further. Identical VMs that grow or shrink with load, perfect for web front ends that spike at lunch and quiet at night. Azure Functions is serverless compute. You write a function, set a trigger, and Azure runs it only when events arrive. No idle servers to pay for. Batch handles large containerized batch workloads. Think overnight rendering or data transforms. Service Fabric orchestrates microservices and containers for long-running distributed apps. And cloud services help you build cloud-based apps and APIs with managed roles. The pattern is simple. Pick the compute shape that matches how long your code runs and how much OS control you need. Long-lived full OS, virtual machines. Event-driven snippets, functions. Microservices mesh, service fabric. Compute without a network is a server in a locked room. Azure's networking tools wire everything together, and back to your building if you need it. Virtual network is the private address space for your resources. You can peer networks and even connect them to on-premises data centers. Load balancer spreads traffic across healthy instances. Application Gateway adds application layer routing and web application firewall features. VPN Gateway creates encrypted tunnels over the public internet. ExpressRoute is the premium path, dedicated private fiber into Microsoft's backbone when you need consistent latency and isolation. Azure DNS hosts your domains. Content Delivery Network caches content near users worldwide. Traffic Manager routes users to the best regional endpoint. And Network Watcher gives monitoring and diagnostics when something breaks. Here's the practical takeaway. Design the network first. Address space, hybrid connectivity, and traffic entry points decide how secure and resilient everything else can be. Data is the other half of every application. Azure's storage and data services cover blobs to big data clusters. Blob storage holds unstructured objects, images, backups, data lake files. Queue storage decouples producers and consumers with simple message queues. File storage offers shared file shares in the cloud. Disk storage backs virtual machine disks with persistent, high-performance volumes. Data Lake Store is built for analytics scale data. Backup and site recovery protect workloads and fail them over when disaster hits. On the database side, Azure includes several SQL-based databases and related tools. Managed relational engines so you don't babysit patches and replicas yourself. For big data and analytics, HD Insight brings Hadoop, Spark, RServer, HBase, and Storm clusters. That means batch jobs, streaming pipelines, and machine learning prep can all land on the same platform as your apps. Store hot operational data close to compute. Park cold archives in cheaper blob tiers. Analyze the rest with managed big data tools. Azure Storage Story is really about the right tool for the temperature and shape of your data. Modern apps rarely ship as one giant binary. They ship as containers, web APIs, and mobile clients, and Azure has first-class support for each. On containers, Azure Container Service supports Kubernetes, DCOS, or Docker Swarm, so you can run orchestrated container clusters with the control plane you already know. Container Registry stores your private images next to the compute that pulls them. Microservices tooling ties those pieces into deployable systems. Web and mobile services make building and deploying applications straightforward. Managed app hosts, APIs, and mobile backends without standing up every server yourself. Developer tools close the loop. Visual Studio Team Services. Today's Azure DevOps lineage covers repos, pipelines, and release. Azure Dev Test Labs spins up sandbox environments for experiments. Hockey app handled mobile app deployment and monitoring. Xamarin enables cross-platform mobile development so one C# codebase can reach multiple phone platforms. The through line: Azure isn't only a place to host finished apps, it's also the factory floor. Containers, CI/CD, and labs, where those apps get built. Three more pillars turn a general cloud into a platform for intelligent, connected, trusted systems. AI and cognitive services let you add intelligence without training every model from scratch. Computer Vision API understands images. Face API detects and compares faces. Bing Web Search brings web scale retrieval. Video Indexer extracts insights from video. Language Understanding Intelligent Service, LUIS, maps natural language to intents your app can act on. Internet of Things is the bridge to the physical world. IoT Hub ingests telemetry from millions of devices. IoT Edge pushes compute out to the device so decisions happen even when the network blips. Combine those with machine learning, analytics, and communications services, and a factory floor or a fleet of trucks becomes a live data product. Security and identity wrap the whole estate. Security Center, now part of Microsoft Defender for Cloud, watches posture and threats. Azure Active Directory is the identity plane for users and apps. Key Vault guards secrets and certificates. Multi-factor authentication adds a second factor so a stolen password alone isn't enough. Intelligence, things, and trust stacked on the same fabric you use for VMs and storage. So why do teams choose Azure once they understand the machinery? 5 practical advantages. High availability. The infrastructure is designed to keep working even when individual components fail. Multiple racks, regions, and failover paths. Data security. Tools like Microsoft Defender for Cloud, Key Vault, and Azure Information Protection help protect data in the cloud, not as an afterthought. Scalability comes in 2 flavors. Vertical scaling changes the size of a resource, a bigger VM. Horizontal scaling adds more instances. Together, they absorb spikes without a forklift upgrade. Cost effectiveness. Pricing models let you pay for what you use, reserve capacity when you know demand, and shut down what you don't need. And the learning curve is approachable for many Microsoft Stack developers. Languages like C# and Visual Basic, plus tools such as Visual Studio and Azure Machine Learning Studio, meet people where they already work. Pull the thread together. Azure is virtualization at data center scale, steered by an orchestrator and fabric controllers, delivered as IaaS, PaaS, and SaaS, plus AI, IoT, and security on top. When you create a VM, you're not magicking a computer into existence. You're sending a request into a carefully designed control plane that finds capacity and spins a hypervisor-backed machine just for you. That is how Microsoft Azure works, and why it can feel like the whole planet is your server room.